Hey everyone, Krishna this side, and I welcome you all to this channel. So let's solve this lead code question 2327. Number of people aware of secret. Okay, bit late to upload video, as in I was really busy with a lot of other stuff. Sorry, I got call. Yes, let's solve this one. Good question to consider. Okay, let me read the problem statement. On day one person discovers a secret. Okay, so you are given an integer delay, which means that each person will share the secret with new person every day starting from the delay days after discovering the secret. You are also given an integer forget, which means that each person will forget the secret forget days after discovering it. Okay, a person cannot share the secret on same day they forget it. Okay, or on any day afterwards. Okay, so given an integer n, return the number of people who know the secret at end of day n. Since the answer may be very large, we have to return it into the modulo. Okay, I guess question is clear with this problem statement, but still let us see the example as well. So here n is basically 6. That means like in total we have 6 days and there is delay of 2. So every person after 2 days he will start sharing the information with another new person. Okay, and here the forget is basically 4. That means after fourth day or fourth day onwards, the person who started sharing the information, right, he will forget it. Whatever the information that he was started spreading out, he will forget it after fourth day onwards. Okay, so yes, on day one, suppose person naming one, he actually got the secret. That means on day one person knows about it. On day two, only person A is actually knowing the secret, right? Because he cannot share it because the delay is basically 2. So on day 2 he cannot share the information, but on day 3 he can share the secret with new person because delay is basically 2 days. So on day 1 he got the information, on day 2 he cannot share it, but on day 3 he can share it because he has here the delay is basically 2 days, right? So on day 1 and day 2 he cannot share it, but on day 3 onwards he can share the information. So he shared it with B. So here two people knows the secret. On day 4 A also shares the secret to new person, but B cannot share the information, right? Because again any person who knows the secret, he will start spreading that information with other ones after delaying 2 days. Okay, so on day 4 B cannot share the information, but A shared it, and there are 3 people who knows the secret. On day 5 A will forget the secret because here the forget is basically 4. So day 1 minus day 5, if we do, 4 days will be there. So on day 4th he will definitely, on day 5th, sorry, he will forget the secret. So B share the secret because now B actually got the activation, so delay is been done. So B started sharing the secret with new person. Let us suppose D is the new person. So in total 3 people knows the secret on day 5. On last day B shares the secret with E, and C also got activated. Okay, because on day 4 C got the information, so he can start sharing that information with another person. Okay, in total on day 6, total 5 people knows the secret. So this 5 is something what we have to print into the output. I guess the question is pretty much clear what it is trying to say. Still I'll explain you with some other examples, and then we'll try to solve it. In the constraints, if we notice here, the n value is basically go all the way to 10 to the power of 3. Okay, 1000 is the value that we have. So obviously we can solve this one with the help of n square as well. Whatever the brute force approach that we are getting it, with the help of that we can solve it. But still we'll see how we can optimize the code as well at the end. Okay, here delay is basically less than this forget. So this is something we can remember. Now let's try to see how we can approach to this one. Okay, pretty much straightforward. Whatever the brute force approach is there, right? So we can solve it with very easy way. Okay, let me connect the screen and I'll explain you the brute force solution, and I'll also show you the code, and then we'll try to optimize it. Okay. Okay, I hope the screen is visible to you all. And there are a lot of many ways to solve this one. And I'm not going to discuss the recursive way and all. Directly explain you n square solution, the brute force solution, and then we'll discuss about the optimal solution. Okay. So here n is basically 6. That means on day 6, how many people knows the secret? That is something what we have to figure out. So starting from day 1, okay, on day 2, day 3, day 4, day 5, day 6, there will be multiple people who know the secret, right? We are not pretty much sure like how many people knows the secret on each day, but on day 1 we are pretty much clear that only one person is there who knows the secret. Correct. Now this particular person basically starts spreading the information from delay onwards. This particular delay, whatever this delay value that is given to us, right? After this delay he can start spreading the information. That means on day 1 he knows the information, so he can skip this one on these 2 days. Okay, these 2 days he can skip because the delay is basically 2. After this delay, he can start spreading the information. So on this particular day 3, he will inform to another person. Okay, new person is there who got this information. Okay, on day 4 also he can spread the information, right? Now, can he basically explains this whatever the secret that is there, can he share it on this day 5? That is the question. He cannot spread this information on day 5 because he forgot that information. Here the forgot value is basically 4. So on day 1 he got the information 1 plus 4. If we do on 5th day, directly he will forgot it, correct? That means he cannot spread this information going ahead from day 5, right? So he created two different persons. On day 3 he shared it with one person. On day 4 he shared it with one person. I guess this particular thing is clear. Now we will see that on day 2, do we have any person who can spread this information? We don't have any person, right? So we will skip this one. On day 3 we see that there is a person, who can spread the information. So now from which day onwards he can spread the information? Of course, this particular day, day 3 plus this delay. Okay, that means on 5th day onwards he will start spreading the information. So from fifth day onwards, let us suppose we don't have any person, right, on this particular day, right? So we will add one person right over here. On 6th day also he will spread the information, because this whatever the forget information that we have, right, it is 4. So from 3 plus 4, if we do on 7th day he will forget it. On 7th day he will forget it, but here the range is basically 6. So yes, on 6th day he can easily spread that information, right? Now this particular is done. Now we will go and see on 4th day. Do we have any person? Yes, of course we have one person who can spread the information. On from which day onwards he can spread the information, right? That is the question. Again, like this 4 plus delay. Okay, 4 plus delay onwards, like on 6th day onwards he can spread the information. So whatever previously on 6th day there was one person, right? So we will add one into that. Simple. So here it is basically 2. Correct. So that means like on 6th day onwards, he will spread the information. On 7th day also, he could spread information, but we have range till 6. Okay, that this person's job is done. On 5th day, we have one person. But the problem is from the 5th day onwards. Okay, if I add this delay, 5 plus 2, 7th day is not there. 7th day is not there, to which this 5th person is going. On the 5th day, whatever the person that is there, he will try to spread the information. So he cannot further go ahead. Same goes with the 6th. Here, two people we have. These two people will spread two more persons. Okay, whatever the information that is there from this 6 plus 2, okay, that is 8. If we have range till 8, so on day 8, he will, these two people will add two more peoples, correct? So these two people will spread this information to two more people. That is the whole idea. So what we are trying to collect here, all these values basically denote new persons that are there on each particular day. Okay, on that particular day, how many new persons that got added, who got to know this particular secret. That is the whole idea. So logic is pretty much straightforward. What we will do is we will start one for loop going from this all the way from day 1 till this day 6. We will maintain an array. Okay, this particular array is there. So this, let us suppose we will call it as a DP array. So this DP array will be starting from 0 index all the way to this day 6. That means in total 7 index will be there. So day 1, day 2, day 3, day 4, day 5, day 6. Okay, this is the DP array. These are the indices. Okay, let me just correct it. So these are the indices of the DP array. So in the 0 of the day, we don't have any person, but on day 1, one person knows that information. Okay, and this is the information. So this is something what we are trying to fill, right? So whatever this particular logic that I have explained, that is something what we have to perform right over here. So on day 1, one person knows that. So for this particular one, what we will do is this was our first for loop. First for loop basically starts from I equals to 1. It goes I less than or equals to n. Last till the last day, we are running this first for loop. Second for loop is like we will run this from j equals to I plus delay. Okay, I plus delay, whatever this I that this person is there, right, on the ith day plus delay. After that he will keep on adding one person, correct? So this goes all the way to I less than. Okay, here the logic is like whatever the minimum value that we have, minimum value between n, okay, less than or equals to n comma whatever this I plus forget minus 1, I plus forget minus 1, till that day he can add persons, correct? From the delay onwards to the forget day, till that in between this he can keep on adding one persons. That is the whole idea. So we will run a for loop and we will update this DPI. So here what we have to do is in this DP of j, whatever the DP of j that we have, we will add whatever the value that we have on DP of I. So here dp of I, whatever the value of dp of I, that means if there was only one person, he is basically trying to spread the information. So in the dp of j, particularly dp of j, we will add one person. If there are two persons that are there on dp of I, okay, the index that we are currently at, so two persons will add two more persons. That is the whole idea. So this was the pretty much straightforward simple code that we have to do. So here the first for loop will take n time and second for loop will take n time. So in total n square is the complexity that we have. Now the idea is we have to calculate how many persons that are there who knows the information, right? So pretty much clear. So whatever this n that we have, n minus forget plus 1, okay, n minus 1 forget plus 1 to this n, okay, in this between this particular range, in this dp array, all the persons that are there, all the persons that are there, n minus forget plus 1, that is the index, okay, that is something what I am talking about, to this n last index that we are at. So all the persons that are available in this particular range, those persons knows the secret. So we just have to add all of them. That is the whole idea, simple, because we are not maintaining on all the days, whatever the date that we have, right? Here we are just maintaining the new persons that we are just adding right over there. So this is like new person, we are not just adding all the previous persons also, we are just maintaining here new persons in all these indices, okay. So on day one only one person knows the secret. On day three, here new person, that is something what we have added, okay, that is something what we are maintaining. We are not maintaining like the previous person that was there, that is something what we are not adding here. We are just adding new persons, that is something what who knows the secret, okay, that is the values that we are maintaining here. I guess this pretty much straightforward solution is something what you guys know, get it clearly. Let me show the code as well for quick. Okay, I hope the screen is visible. So here we have to write the code in mod m. Okay, so mod is something what I have considered right over here and have created this dp array which is having size n plus 1, obviously, because at 0th index we don't have any person who knows the secret. But at first index dp of 1, we know that one person is there who knows the secret. That is something what I have filled right over here. Now we will run a for loop from first index onward to the last index, and here we can slightly modify this. Instead of going last index, we can go till n minus forget plus 1. Till those days also we can go and we can keep on updating the values, okay, that is completely fine. So at dp of I, if there is 0 persons that are there who don't know any particular secrets on that day, so we can say, simply continue from there, okay, slight modifications, nothing fancy. So we are starting from I plus delay, okay, because from that particular day onwards, any particular person that is available on this dp of I, okay, that person will keep on adding new persons, okay, he will keep on spreading that information to other persons, and this j goes all the way to n to I plus forget minus 1, okay, because till that index he will go and he will keep on updating it. So whatever the minimum value that we are getting it out of these two, that is something what we have to consider, and dp of that particular jth index, we will add this dp of I. So if there are two persons will add two more persons in that particular index. That is something what we have to consider. Once we are done with these two for loops, what we have to do is we have to start from n minus forget plus 1 from that particular index to the last index that we have, and we have to collect all the new persons that are available in that particular range, because from this n minus forget plus 1, all the persons that are there, they will not forget it till this last index, right? So those all the persons is something what we have to keep on adding it into the answer, and answer is something what we have to return. Okay, this was the brute force solution. I guess it is pretty much clear and straightforward. Now slightly, if we stress on this particular solution only, we can get optimal solution as well. Here it is taking n square complexity, but we can make it in big O of n as well. Okay, how we can do that, that is something what I'll try to explain you guys, okay. All right, so in previous approach, right, so what we have done is we actually went forward, okay. So we went forward, we keep on updating whatever the persons that is there, right, for this first index person that is there, delay plus this index that is there, right, delay plus this index, from there onwards I plus forget, this was basically exclusive. Till that particular index we keep on adding new persons. That was something we tried doing it, right? But if we think in reverse direction, right, so let us suppose we are at this particular index, on third index we are right over here. So here what we can do is, if we try to perform this operation I minus delay, okay, okay, just trying to perform the reverse operation. Here we actually went forward, but here what we will do is in reverse direction we will go, okay. We will check that if I minus this delay, if there is any person, if there is any person in the dp array, if there is any person that is available, that person can generate here new person. Can we say that? It is pretty much straightforward, right? Like in previous operation what we have done is we went forward from this particular I plus index to this particular index, we keep on updating the values. That is something what we have done. But on this particular index, what we can do is we can go in the backward direction, like I minus delay. That is something what we will try to do. So here the range is like I minus delay on that particular index. If there is any person, that person definitely, it is guaranteed that that person will add new person at this point in time on this particular third index. So what we can do is we will maintain persons. Okay, whatever new persons that we are getting it in the going ahead, those persons count is something what we will keep on maintaining. So here I have created a persons count. Okay, so persons count is something what I have created, and our range basically, when we try to look in the backward direction, right, our range basically starts from I minus forget. Okay, this I minus forget is something what we will check on that particular index how many persons that are there. Those persons definitely it is guaranteed that in this particular third index, let's suppose here I minus forget, if we go, if we have that particular value in the DP array, those persons, it is guaranteed that those persons will forget to update this particular one. That means like those persons that are there I minus this particular index I minus forget, on that particular index whatever those persons that are there who will keep on adding new persons, it is guaranteed that those persons will forget it. Okay, that is something what we will keep on subtracting on this one. So I minus delay, whatever the persons that are there, those persons we will keep on considering here, and we will go and we'll check that I minus forget. Okay, on that particular index, if there is any person that is there, that is something what we are keep on maintaining, right? This person is something what we are keep on maintaining it going ahead. Okay, while looking into this backside, we were any person that we found it, that is something what we are updating right over here. Okay, so I minus delay at that particular index, if there are two persons count is something what we got it, and we will check that if I minus forget, if there is any index that is available and there are persons that are there, those persons will definitely forget to update this particular index. Okay, those persons will forget to update this particular index. So in this persons count, we will subtract that I minus forget persons. So whatever the persons that we got it, the count of those persons will be updating in this particular index. I guess the idea is pretty much clear. Let me update this particular one. So here I minus forget. So these values should be greater than 0. Okay, because at 0th index 0% is there. Okay, and here going back side, we don't want to go in the back direction, right? So here what we will do is we will start from the delay index directly. From the second index we will start. So here what we can do is of course, like delay minus this I minus delay, something that we do this whatever the index that we have, dp of I minus delay, it basically takes to the 0th index. So obviously what we will do is we will start from this one, because we know that from the first index onwards only one person is there who knows the idea. So why to just basically explore all these indices, right? So simply we will start from the third index, that is like delay plus 1. From delay plus index we will start, and we will check, we will keep on adding these persons. Okay, whatever the previous persons that count that we have, we will add it. So here when we perform this operation, dp of this whatever this I minus delay, okay, I minus delay, here dp of I minus delay is basically we will go at this particular index. So here the value is basically 1. So here we got one person who will update this index. Okay, who will spread information to this person that is on this third day. Okay, so here whatever the persons count that we got it, so from here what we have to do is we have to subtract this I minus forget. So we will simply check that is whether this I minus forget is actually greater than 0, because from the 0th index onwards only, sorry, this first index onwards only, people knows that there are people who will keep on forgetting things, right, going ahead. So that is something what we have to consider. I minus forget is going to be should be greater than 0. That is, these are indices. Okay, nothing but these are indices. So I minus forget is should be pointing, that means this first index, that person that is there, he will forget going ahead. So we will simply check that if I minus forget, if it is greater than 0, so from these persons, the persons that we are maintaining, we will subtract this dp of, we will simply subtract this dp of I minus forget. Okay, I minus forget, we will simply perform this operation. That means on this day 3, on this day 3, we will get to know whatever the previous persons that are there, those persons will spread the information that count we are maintaining in this person, and we are simply subtracting this dp of I minus forget, those persons who basically forgot to update this value. So simply if we do that, we will get all the people who are basically new persons that are there who are getting generated going ahead. That means who are getting this secret, they are getting this whatever the secret information that is there, they are basically acquiring it. Okay, I guess this idea is pretty much clear. Whatever going forward operation that we are trying to do, we are simply trying to go in the backside, and we are based on persons that are available on that particular index, based on those persons we are updating this dp array. So if I have to update this one, simply let me do that. So here on this dp of here, only one person was there previously, and we don't have any forgot person, like we don't have information that any person who forgot this information, right? So here the value is basically on this one, there was one new person, that is something what we have added on this day 3. Now on day 4, we will simply again perform this operation. So here this value is basically take us at this particular index, like day 2. I minus delay, if we perform this operation, it will take us on this day 2. Okay, on day 2 there are 0 persons who knows this information, because we are already maintaining this person's count, right? So one person is something what we have already considered. So here there was only one person. Now again, when we perform this 4 minus forget, basically 4, we are going to add this 0 index, so we are not considering. So whatever the person 1 is there, that is something what we have to update, because this person that we got it, right? So that person basically keep on spreading this information. Okay, there was one person, that is something what we got it previous time. In the previous time, one person was there who is keep on updating these values, and he still has not forget it updating the information, because we are trying to see also this I minus forget whether that any particular index person, that is something that he forgot it updating it. Okay, so simply if we perform this operation now at this fourth index 430 also, we got one person. Now when we perform, we reach at this day 5, when we perform this operation I minus delay. So I minus delay is basically taking us to this third index. So there was one more person who can update this fifth day, update this fifth day. That means he can add one more person. So what we can do is, previously there was one person, so we will simply add one more person into that one. Okay, whatever the value that is there on this DP, okay, on this day 3, that is something what we will add it into this person. Okay, so we got two persons who can update this day 5. Again, we have to check that I minus forget whether any particular person that was there in a previous time who forgot to now, and who cannot update this 5. So we will simply check that here 5 minus forget is basically 4. So the day 1 person definitely forgot it updating this one. That is something what we will get to know right over here. So here the idea is pretty much straightforward. From this person to, we have to subtract one person. That is like on day 1 all the persons that are available, that is something what we have to subtract it. So simply here again value is basically 1. So one person is something what we have added on this day 5. Only one person is there who knows the information on day 5. That means only one new person. Okay, only one person. I'm not let me correct this statement, because on all the days we are just adding new persons, okay, who knows the information. On day 6 also we will perform the same operation, but here the information goes update to 2, I guess. That is not it will happen, because when we perform I minus delay, here person was 1. So here we have to add one person again, because 6 minus 2 is basically take us to the fourth index, and at fourth index I guess the value was 2, right? Sorry, here no, it was 1. So here again the value was 1. So 2 is the two persons that we have. Now here from I minus forget basically goes at second day, and say on second day we don't have any person particularly. So obviously on day 6 we have two new persons who got added on this one. I guess this particular approach is something what you get this, and let me write down this particular code, and then we are done. Okay, so let me restart this one. So let me set here the mod first. Mod is basically 3 4 5 6 7 8 9. Okay, now what we can do is we can maintain a dp array, new int n plus 1. Correct. So it is taking time to update. Now what you have to do is we will maintain persons count, new persons who is something what we are maintaining, right? So how many new persons, that is something what we are adding it. And dp of 1 is basically equals to 1. We will run a for loop starting from int I equals to delay, from delay plus 1. From that particular day onwards we will run a for loop. And what we can do is obviously here I should be less than or equals to n, and I plus plus. And whatever the delay dp of delay minus 1, dp of I minus delay, that is something what we have, we will add it into the persons. That means those persons are responsible to create new persons who can spread the information. Okay, so dp of I minus delay. See, I can start from zeroth index as well, but I have to just maintain if conditions, and I have to make sure that boundary conditions are basically is getting satisfied. So for that, I just have added this one. And here, if condition is something what I have to check. If I minus forget, if it is greater than 0, okay, because from I minus forget is basically from first index onwards only persons are there, right? So obviously it should be greater than 0. If this particular condition is satisfying, so from this person I have to subtract it. Okay, I have to maintain this as well. So dp of I minus forget. So all the persons who are basically forgetting it, those values something I have to subtract from this person's count. Okay, so here persons minus I minus forget. Okay, here we have to maintain this mod. So obviously this value sometimes dp of I minus 1 should be while applying this mod, right? Here previously we have to apply the mod as well. So here persons plus dp of I minus delay. This value can, when we apply moderate, this can be go smaller. Okay, if it goes smaller when we subtract this from persons, we may get a negative value. So obviously we have to add mod here. Okay, just to make sure that these values are properly updated. And once it is done, we have to simply update here mod. Okay, I guess this is something what we have to do. Once we are done, we got to know like these many people's new persons, something what we have added. We have to simply update this into dpi. Okay, once we are done, again I have to run a for loop for I equals to, basically it goes from n minus forget plus 1. From that particular index onwards, all the new persons that are there, they will not forget the information till the nth index. Those something those persons is something what I have to consider here. In this answers equals to answer plus dp of I. Here again I have to apply the mod. uh, Now we have to return this answer at the end. Okay, let's see if it is working fine. So this particular for loop we are running only one time. Again, this particular for loop is also running one time. So obviously this time complexity is big O of n. Space is obviously we are using big O of n. Okay, let me try to submit this code and see if it is working fine. Okay, it is taking time. It got accepted. I hope you get the idea what I have been trying to explain you. If so, please make sure to like this video. Thank you for watching this one. Bye bye.